Hello guys, my name is Balkrishna Srivastava and welcome to Code with BK. So in this video, we write a C++ program to convert a decimal number to its binary equivalent. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 3 or 4 are subscribed. More than 95% of my audience is not subscribed to my channel and a subscription is very important. So please do subscribe to my channel. So we have to write a C++ program to convert a decimal number to its binary equivalent. So let's look at the examples. We have n equal to 10. So the decimal value here is 10. The corresponding binary value is 1010. The decimal value in the second case is 16 and the corresponding binary value is 10000. Okay. Alright. So first I am going to tell you how to convert a decimal value to its corresponding binary equivalent. Okay, and then I'm going to code that method into the C++ program so that for an integer n that holds a decimal value, we are able to find the corresponding binary value. Alright, so what are decimal numbers? Okay, so decimal numbers are basically values that we use in our day-to-day lives. Okay, for example, say 14, 7, 8, 91 and 28. Okay, so we are using these values into our day-to-day lives, and this is very comfortable for us to understand that this is 14, this is 17, this is 8 and so on. Okay, technically we call them decimal values. Why? Because the word deci, okay, means 10. Okay, deci means 10 and we are using 10 symbols to represent any quantity. Okay, we have 10 symbols as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so using 10 of these symbols we are able to represent any quantity, and this is called the decimal number system. Okay, so just as we have a decimal number system, we have also a binary number system. Okay, binary number system is the same, that you have to represent a quantity using symbols. Okay, in this case we have only two symbols. Okay, the word bi means 2. Binary number system has two symbols, 0 and 1. So decimal number system has 10 symbols, binary number system has two symbols, but using these two symbols only we can represent any quantity. Okay, for example, if you want to represent 7 in binary, it comes out to be 111. Okay, 8 in binary comes out to be 1000. Okay, these both represent the same quantity. Okay, but the number system uses different. Okay, and how do we put this formally? We say 7, okay, in base 10, okay, that is in decimal number system equal to 111. Okay, and the base of binary number system is going to be 2 because it uses two symbols. So 7 in base 10 is equal to 111 in base 2. Okay, this is what you call it for. Okay, so I hope you understand what a decimal number system is, what binary number system is. Okay, deci means the word 10, it means it has 10 symbols to represent any quantity. Binary number system has the word bi, which means 2. Okay, two symbols to represent any quantity. Okay, and this is how we represent two quantities in the a different number system. Okay, same quantity in two different number systems. Okay, all right. Now how did I get 1000 from 8? This is a very standard way to convert a value from a decimal to binary number system. Let me tell you that. Okay, so if you want to convert say 8, okay, to corresponding binary value, okay, you keep dividing it by 2, okay, as long as it does not become 0. All right, and we append the remainders. Now what do I mean by that? When you divide 8 by 2, your quotient is 4, your remainder is 0. Okay, so this is my remainder. Okay, you divide this value 4 again, so quotient is 2, remainder is again 0. Okay, you divide this value by 2 again, 2 divided by 2, quotient is 1 and remainder is 0. Okay, you divide this value by 2 again, quotient is 0, remainder is 1. Okay, so we kept dividing the decimal value from 2 as long as it did not go to 0. Okay, and we append the remainders from bottom to top. Okay, so we get 1 first, then 0, okay, then this 0, okay, and then this 0. Okay, this comes out to be the value into base 2 equal to 8 in base 10. Okay, all right. Similarly, if you want to say convert 7, okay, we keep dividing 7 by 2 as long as it does not go to 0. Okay, So 2, when 7 is divided by 2, we get quotient as 3 and remainder as 4. Okay, we divide this value 3 again by 2. Okay, quotient is 1, 2 ones are 1 and remainder is 1. Okay, we divide this value 1 by 2 again, quotient and 0 and remainder is 1. Okay, we append these remainders bottom to top, so we get 7 in base 10 equal to 111 in base 2. Okay, alright, and this is the exact method that we use in our code. Okay, we convert a decimal to its corresponding binary value using the exact same method. Okay, so I am going to write a function string decimal to binary. Okay, takes an integer n. Okay, so the data type to hold our decimal is going to be an integer, an int value, and the data type to store our binary values are going to be strings. Okay, so our strings of zeros and ones will be returned for this corresponding integer value. Okay, so what was the method? We keep dividing the decimal value by 2 as long as it does not go to 0. So while, okay, n is not equal to 0. Okay, we divide it by 2 and we store the remainder. Okay, so I'll get the remainder as n%2. Okay, percent symbol is used to get the remainder, so n%2 will give you the remainder when n is divided by 2, which we are doing here. Okay, a divided by 2 gave me remainder 0. All right, okay, and then we need the quotient, so I do n equal to n by 2. Okay, we divide n by 2, right? We need to store these remainders in a string. Okay, because the binary equivalent is all these remainders from bottom to top, okay, appended together. All right, so I say string binary equal to blank. Okay, and then we append this remainder to binary, so that in each iteration we append each remainder into this binary and we get the final binary value. Okay, because if you look at this example, all right, we have to append, to convert 8 to binary equivalent, we append 100. Okay, 130. So in our first iteration we append 0, in the next 0, and the next 0, and then in the next one. Okay, so it looks something like this. Okay, so if our string starts with blank, okay, for this case, all right, I append the first 0. Okay, so it becomes this. Then I append the second 0 in front. Okay, here, right, then I append the third 0 again in front, it becomes this. Okay, then finally append the fourth one in front. Okay, so it becomes this, which is the value here we are looking at. Okay, so I say if r is 0, I append 0, if r is 1, I append 1. Okay, I cannot directly do binary equal to r plus binary. Okay, because this is not Java, right? We have to make sure the data type that we are appending to a string is actually a string. Okay, so if r is 0, I append a 0, else if r is 1, I append a 1. Okay, right, and we then divide n by 2 and store the value back into n, because we keep dividing n by 2 as long as it does not go to 0. So this will give us the corresponding binary equivalent which we finally return. Alright, following the same idea, keep dividing the value by 2 as long as it does not go to 0. Okay, in each iteration we get the remainder, here. Then we write an if else, if r is 0, we append 0, if r is 1, we append 1. Okay, there are two possible remainders only, 0 and 1, and finally we divide n by 2 and store it back into n. Okay, let us run this for some cases. So I say int integers equal to, okay, right, I say int num integers you can find as size of integers by size of int. Okay, I iterate this array, okay, using a for loop, pick up each integer at this location is integers of I. Okay, then we print cout. Okay, this integer I, which is this integer x in base 10. Okay, we will try to print it in the same way, in base 10 equal to this equivalent base 2. Okay, so base 10 I'm going to print as subscript 1 and subscript 0 together, right, which is equal to, okay, the corresponding value in binary, so decimal to binary for this integer x, okay, this is in base 2. All right, okay, so it will print the value something like this: 7 to the base 10 is 1 in base 2. Okay, yeah, all right. So let me test this. So g plus plus and g plus plus. Okay, so once I have an extra white space somewhere here. Okay, clearing, compiling, and run. Okay, so 10 in base 10 is equal to 1010 in base 2. Okay, so examples we took were 7 and 8. We have 7 as 111, we don't have 8, we can add 8. Okay, so we can say 8 is somewhere here. So clear, compile, and run. Okay, so 8 is 1000. Okay, just as is we did here. Okay, 7 is 1 triple. Okay, so 2 is 10, 14 is 1110, 18 is 10010, 7 is 1 triple, 23 is this, 16 is this. Okay, so you can see 16 plus 7 is 23, right? So in this 16 you add these. Okay, so 1000 plus 00111 will give you this. Okay, this 111 comes here in this. Okay, then 31 is this, 100 is this, and 8 is this. Okay, all right. So this was your code to convert decimal to binary. All right, you can also do this recursively. If you want that code, let me know in the comments. I'll add that code as well, right? Because this is an iterative method, it can be converted to corresponding recursive method as well. All right, so if there was a part that you did not understand or was not clear to you, please let me know that in the comments. I always try to answer all your comments. All right, and you can always let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. So please let me know your thoughts about this video in the comments. Please like this video, please subscribe to my channel, and thank you for watching.